Good morning, afternoon, good evening, everyone. Uh, my name is Ahmed ElZeftawi. I am your instructor for today. I have been with PioPetro for the past, I think, 3 years now, but I am in teaching since 1995. Uh, I am teaching the well intervention course and the cold tubing operation course. I have been in teaching since that time, and I conduct this course that we are going to discuss it in a while, which is the well intervention. I've been teaching this course in about 18, 19 countries around the world. My background is mechanical engineering, graduated back in 1983 from Cairo, Egypt. I'm Egyptian. And this is our fifth session this year. One more session left, which I think will be next Saturday. We have been discussing the components of the well intervention course, and today we will discuss wireline. The session will last about 1 hour. During the session, you might have questions. Please just put it in the question bank you have, and I will look at it at the end of the session. I'll go through all your questions and try to answer it if I can. My background, since I graduated from Faculty of Engineering back in 1983, I worked with service companies. I worked in wireline and cold tubing, in well testing, in completion. Later on, I specialized in the cold tubing, and I work as even as a consultant for investor to create stimulation companies in many countries. But let us go back to the course. This is a simplified, this is not a condensed well intervention course. We try to go as simple as possible because I know that you are undergraduate. So I will not go into these specific details of the topic. So we will go through just general knowledge about the wireline types, how it works, and we will concentrate on the pressure control equipment, or VOB, lubricator, risers, stuffing box, grease, injection head. So let's start. The wireline, it is a well intervention technique, and well intervention, from my point of view, it is a science to teach us how to deal with life wells. Because dealing with life wells needs special skills, special treatment. Because life wells, you are talking about pressure. Pressure is the killer. If you didn't do how to deal with a killer, you will die one day. So a wireline, it is a well intervention technique to convey tools and an instrument downholes. The wireline itself will not help you by doing anything without downhole tools that you run in. And it is definitely the most effective practical method to diagnose a well problem. If we have a problem in a well, first thing we think of is to run what we call a gauge cutter. This gauge cutter run, the moment he stops, you have a problem at that particular depth. In categories of a wireline, I used to say we have three categories. We have slick line, we have braided line, we have E-line. But now I cannot stop. I have to continue because we have two newcomers. We have the digital slick line and we have the fiber optic cables. The slick line or solid line or piano line, this is the one you see it in front of you. This is what we call slick line, piano line, solid line. The braided line is a multi-strand wire. multi-strand wire, and we have an E-line. An E-line, which is the multi-strand wire, yes, like this one, but I wonder if you notice there is a cable inside. Maybe you'll not be able to see it clearly, but there is a cable inside. It's a multi-strand wire, as you see here. You see, it's multi-strand wire. And we have the digital slick line. The digital slick line which is the newcomer. It is a slick line, but it has a coat at the surface. This coat can transmit the data in and out. And then we have the fiber optics. The fiber optics, which is the new technology we have even in communications, which transfer the data in the speed of light. Speed, not sound, speed of light. The slick line, which is a single strand wire, normally the size is 108. This is the diameter. The 108, this is the 118. We use it in the normal application like running plugs, sitting downhole seat valve, uh, running gauge cutter, impression block. This is the kind of normal operation we do with the slick line. But when we talk about fishing, we do not fish with the slick line. We fish with braided line. And braided line is a multi-strand. The diameter is much bigger, which is normally 316 or 7/32. This is the common size we use. And this is mainly for fishing operation and swabbing. This is the two main operations that we use in braided line. So keep in mind that we don't fish with the slick line, because when you do fishing, you need a strand, you need a wire which has a high tensile strength. You will find this in the braided line, not in the slick line. The E line or electric line, we use it in what we call here SRO operation, which stands for service readout operation, because it has this cable at the middle. It has the cable here at the middle, and you can transmit data immediately. And we use it also in setting the packer. And we also use it in perforation. We can perforate through it because it transmits signal through this cable, electric cable in the middle. Any wireline equipment, it consists of surface equipment, PCE, which stands for pressure control equipment. This is where we're going to concentrate this course, and subsurface equipment, which is downhole tools. We will not talk about downhole tools. We will concentrate on the pressure control equipment, actually, which is the quick union, stuffing box, grease injection head, lubricator, BOB. This is the item that we need to discuss today. Downhole tools is not part of this course. What you see here is a typical rig up of a slick line, where you see the Christmas tree, and you have here the POB and some sections of riser or lubricator, and we have here the stuffing box. In this rig up, what happens is we have here the winch or the drum that contains the wire line, the slick line. So it goes all the way here through the weight indicator, all the way up to the stuffing box, and goes down to the well. In this rig up, our primary barrier, as we discussed in the first session we had together, our primary barrier is the stuffing box. If it failed, what we will do, we will stop and then apply our secondary barrier. Our secondary barrier here is the BOB. But if you notice, it is two identical BOBs. Two identical BOBs. So these two BOBs, as a classification, it is one barrier, but you double the barrier. So one BOB is history. Nowadays, two BOBs in your rig up is a must. This is regardless if you are working with slick line, braided line, E line, two BOBs, two identical BOBs is a must. So this is your secondary barrier. Our tertiary barrier is the Christmas tree. Which valve in the Christmas tree? It is the upper master valve. Why the upper master valve? Because it is the valves that has the wire cutting capability. So we are not looking for the name, but we are looking for the capability. So your tertiary barrier is the Christmas tree. Which valve? It is the upper master valve. Why? Because it is the valve that has the cutting capability. It can cut the wire without being. If you look at this angle here, this angle has to be 90 degrees. So the weight indicator will give you a correct weight of your tools downhole. If the degree is not 90, the weight you are getting is not accurate. The relation between the weight and the angle is, if the angle is 90, the weight is correct. If the angle is more than 90, the weight you are reading is less than the actual, and vice versa. And if we need to have a closer look, here it is. This is the angle which has to be 90 degree, so your weight can be correct. And of course, we understand that in some situation, you cannot have it 90 degree. That's why we have correction factor. If the angle is 100, you multiply by this figure. If the angle is 85, you multiply by this figure to get the correct weight reading. First thing we put on top of the Christmas tree is the quick union. What you see here is the quick union, which is actually a thread type. And this thread connection is hand tight. Do not use wrench, because what makes the seal is not the thread. What makes the seal is this O-ring that you see, this black spot here. This black spot here is the O-ring. This O-ring. This O-ring that make the seal. That's why we care about this, as we said first session. This has to be brand new, and you use it only one time. So after the job, when you rig down, you have to cut it, kiss it goodbye, not to be used again. But this thread is Acme thread. The Acme thread does not make a C. The O-ring is what makes the C. That's why this is hand tight. And be sure it is clean. The thread is clean. You have to keep it all the way. Never use a wrench. The explosive decomposition, this is a phenomenon that happens to all rubber items you have in your rig, especially in your pressure control equipment, where this rubber absorb gases. So it keep absorbing gases till the full saturation. When it is hot, when temperature raised, gas would like to expand, but it cannot expand because this is a confined space. So what the gas does, it creates blistering, tearing, cracking to this rubber element. And if you remember the first session, we said, if you are dismantling your BOB, which contain 10 rubber items, and you discover that this phenomena happened in one of the items, you have to remove and replace all components because they are exposed to the same environment. One is damaged now. If you change it only after maybe 20 minutes, the other one will be damaged. So you have to change all your rubber elements if this phenomena happened in one of your rubber elements. We discussed this in the first session. Our primary barrier in the wire line is the stuffing box. What you see in front of you is two stuffing boxes. One of them is manual, the other one is hydraulic. The manual stuffing box should be in the museum now. Not now, actually, 10, 15 years ago. we are using hydraulic stuffing box. What makes the seal in both of them actually here in this area? Here in this area. What this area contains? It contains these packings. This packing, and then the wire goes in and out, and this packing is squeezing on the wire, preventing the well pressure escaping to the surface. And again, I explained that before. If you notice these packing, they are different in maybe color, in size, in material even. Why they are different in material? Because I said, when you ask me to go for a job, you need me to do a job. So many questions I have to ask you. One of them is this well is high pressure or low pressure, high temperature or low temperature? Is it sweet or sour? Is it gas or oil? And based on this data, I should select the right rubber I should use to deal with this particular environment. You cannot use a standard service packing in H2S12, for example, right? So you have to select the correct rubber or packing. During the job, your wire is in and out, in and out. There is a friction between the wire and the rubber. Who wins? Of course, the wire. So the wire eats the rubber. So start leaking. When it start leaking, how to stop this leak? You need to let this rubber squeeze again on the wire. In the manual stuffing box, you have to send the monkey on top of your rig up with a pipe wrench to go to this gland nut to squeeze it. So when you squeeze it, it will squeeze the rubber into the wire to make the seal, to effect the seal again. But in hydraulic stuffing box, you don't have to hire monkey in your crew, but you hire human beings. So instead of the gland nut, it is replaced here with piston and cylinder. So you apply pressure on the hand pump. This pressure go into the hoses all the way to the piston. It pushes the piston down to do the same effect, to squeeze the rubber into with the wire again. If you are doing a job and you lost your tools in the hole and you didn't notice that, you start pulling out of the hole. While pulling out of the hole, there is nothing will stop your wire. So the wire will start coming out from the stuffing box out. What comes after? It is the well pressure. So you'll have a blowout. To prevent this blowout from being there, we put this device. This device, we call it plunger. This is the plunger, which you see it here. You see these black spots here? This is the plunger. So as long as the wire is inside, you are safe. Type. Now the wire is cut. You are pulling out of the hole. Nothing will stop the wire. The moment the wire comes out of the plunger, what comes after? It is the well pressure. So the well pressure will push the plunger up to squeeze it in this profile. So the plunger will act as a blind. Yes, it has a hole. I know. See this hole? But as long as the wire is in, the pressure can push it up and down, but it cannot squeeze it. But when there is no wire, the well pressure will squeeze, because the upper part here is rubber. So this rubber will be squeezed as a blind, preventing the well pressure from escaping out. And that's why this plunger, we call it blowout plug or plunger or stuffing box BOD. And this is the stuffing box, actually, the slick line stuffing box, it is unique because it is always your primary barrier, even if you don't have wire inside it. because if you don't have wire inside it, the plunger will be activated and preventing the wind pressure. And it is also unique as the stuffing box as a classification. We said first day in first session that it is closed barrier, but inside it there is a closable barrier. The plunger is a closable barrier because what is the definition of closable barrier? Close when required. So it's open by default. When it will close? When you need it. And now you need it because it will prevent that go out. So the stuffing box, it is always your primary barrier, even if there is no wire. And the stuffing box, it is a closed barrier, but inside it, there is a closable barrier. The stuffing box is really nice as long as you work with slick line, solid line, which is polished, sealable. But if you work with P line or braided line, no rubber can help you because with all pressure you can apply there, the pressure will escape from the strands. So you have to think of something else that make the seal. That's why if we are using braided line or E line, we are using the grease injection head. This is the grease injection head. What make the seal is this part, the blue part here. If we look what's inside it, you will see that it is flow tube. Flow tube. Now we have the wire going inside the flow tube, as you see. What we need to do now is to seal this area, this white area between the ID of the flow tube, the OD of the wire. How can we make the seal? By pumping grease. Fill this area with grease through this system. Before we talk about the system, let me ask you a little question. This flow tube, we made it with brass. My question to you, why we made it with brass? Why not steel? Any idea? Let me see your answers. I repeat my question. This flow tube, we make it with brass. Why we don't make it with steel, with iron? So first answer I received from Ahmed, he said for corrosion. And then another answer to avoid the scaling. Any other answers? I have 38 participants now. Out of 38 participants, I got only two answers. Oxidation to reduce the wear and tear of the braided line. Brass is strong. Brass is strong. Brass is stronger than steel. They resist corrosion better. If this is true, why we didn't make all the equipment with brass to avoid the wear or corrosion, to avoid wearing of the wire, of the line? Okay. Have you heard, guys, of a brass hammer? Why we use brass hammer in some application? Normally, the hammer, it's a wood handle, and at the end there is this block of steel. So this is normally the hammer. Sometimes this block of steel, we put not block of steel, we put block of brass, and we use a brass hammer to hammer, not steel. Why we use brass hammer? To avoid spark. Back to this flow tube where this steel wire is inside. This movement inside steel and the steel spark might create. or to avoid the sparks, we use brass because brass will not create spark. This is very important. We need to avoid spark. Yes, someone said that. Amy, she said to avoid spark. Thanks, Amy. Perfect answer. High temperature? No, the brass is not for high temperature, actually. To avoid the spark. Thanks, Amy, for your answer. Excellent. To avoid the spark. Let's go now to the system. This is the system. It's a pump. This pump will get grease. This is the grease, by the way, we are using. This is the grease. It's very viscous. You see? It starts coming out. You see? You notice it? This is the grease. We call it sometimes honey oil because the color is like honey. The viscosity is like honey, but I never tasted. Uh, uh, we use this grease. So this pump, it takes the grease, it goes to the grease inlet, which is below here, and it comes, the grease outlet come from there back to the pump. So it is a cycle, clockwise direction, with the pressure higher than the wellhead pressure by minimum 1.2. So if the wellhead pressure is 1000, they keep the circuit at least 1200 psi, preventing a well pressure escaping out. But here we have to stop. Many question arises. We need to answer it. Ahmed, if this circuit is higher in pressure than the wellhead, what prevent grease escaping into the well? And what prevent grease escaping out of the well, out of the grease injection head? To understand this, let us discuss. Let us see what's on top of the grease injection head here. It's a piston and cylinder, right? You see this black spot here, which is element wiper. The element wiper acts exactly like your windshield in your car. It cleans the glass. So this braided line, E-line, while pulling out of the hole, it has a lot of grease. So this element wiper, it is in contact with the wire while pulling out, it cleans the wire. And this grease that it cleans it, it goes through this drain hose here out to be thrown out because it is contaminated grease already. This friction between rubber and wire, the wire eats rubber. So the rubber element does not clean. That's why we use this pack of pump. You see it in this figure, this pack of pump. We apply pressure through this piston here on top. It pushes through the cylinder. It pushes the piston down. So the element wiper is in contact again with the wire to clean. This kind of pressure we apply from top. Plus, if you notice, the clearance between the flow tube ID here and the OD of the wire, it is, as you might notice here, I'll write it down, 0.005 of an inch. So the volume you are filling is too small. So the leak you are getting from that is too small. But yes, there will be leak. That's why if you start the job with the drum full of grease, you end up the job maybe with 2/3, the drum 2/3, the drum or 3/4 or half or quarter. It depends on the severity of the job. It depends on the duration of the job. but definitely you will have some you lose. And that's why uh, if you have a closer look to this flow tube design, if you look here, this is a clearer picture or the bigger picture. If you notice here, this is the greased inlet, which is below. This is the greased outlet, which is above. How many flow tubes we have here? One, two. But we have another one here below the grease inlet. This one, we put it below the grease inlet. It has a clearance less than 0.005 an inch to minimize the loss of grease inside the well. Uh, how many flow tubes we should have? This depends on the pressure category. We're going to back to the magic formula I told you about. What's pressure? Force divided by area. From this formula, what is force? It is pressure times the area. So to increase the force applied, leave the pressure alone, increase the area. Increase the area in this formula will automatically increase the force applied against this increased pressure rating you have. That's why when you increase the pressure, you increase the number of flow tubes you have. Back here to this rig up. I said it is a closed circuit, clockwise direction. This is the closed circuit. Some other companies or some other people use open circuit. Open circuit means they pump the grease, it goes through the grease inlet, but the grease outlet, it goes to a container and they throw it. They don't inject it back to the system. This is open circuit. But in closed circuit, since it is this direction, we have a little problem here. The line here between the grease and hydrocarbons. So the grease will be contaminated with hydrocarbons. That's why on the way back, we have to put a filtration system to filter these hydrocarbons out of the grease. In the slick line, we have this device, the plunger, which prevent the blowout in case you lost your tools and you pull out the hole with the wire. Here we don't have a plunger. That's why below the grease injection head, we have what we call SCU, safety check union. This safety check union, we put it below the grease injection head. It is actually ball and seat. As long as you have the wire inside, this ball is on the side. The moment you lost your tools, the wire is coming. The moment the wire comes out of the ball drops to the center. What comes after? The well pressure. So the well pressure will push it. It will sit on its seat here as a blind, preventing the well pressure from escaping out. So it's ball and seat at the end. This is what we call safety check union or ball check valve. We put it below the grease injection head. Below the, so we have the primary barrier, whatever it's a stuffing box or grease injection head. Below that, normally we have two-section lubricators. What you see here is two-section lubricator, but if you notice, I put all type. This one is obsolete 15 years ago because the lubricator these days has to be one piece. This one is not one piece. If you take a cross-sectional area, you will notice that this piece is connected to this piece. This piece is connected to this piece. This piece is connected to this piece. And each connection we have internally an O-ring to prevent a leak. When you increase the number of connections, you increase the possibilities of the leak. That's why when dealing with high pressure, you have to minimize your connection to minimize the risk of leak. That's why the new lubricator should be integral. Integral means one piece. So each 8 foot is made of one piece, no connection. Number 2, this is the lower section. This is the upper section. Can I make this one the lower section? Of course not. Because upper section, of course not, because the lower section should contain all the devices that you can see and operate by your hand. Otherwise, you need wings to fly, to see over there and deal with it over there. So lower section normally it is the one that should contain all the devices you need to operate and look at. Number three, this is a lubricator, not a riser. In my life, for years, I thought lubricator and riser is the same. Then I got some knowledge where now I can recognize that the lubricator is thread connection. The riser is flange connection. Lubricator is thread connection, riser is flange connection. Our second barrier is the BOP, blowout preventer. What you see in front of you is a BOP. We call it single actuator. Any BOP regarding it is single, double, triple, quad, wireline, coiled tubing, snubbing. You will always notice that we have this equalizing valve. This equalizing valve, from its name, it is to equalize the pressure. Because during the job, if you have an emergency situation where you need to close your BOP, so now you close your BOP, bleed off the pressure above to zero, and then fix the problem you have on top. Now we need to resume an operation. We need to open the BOP. How you open the BOP? The BOP is closed, zero above, maybe 3,000 below. You cannot open with this differential pressure. You have to equalize it. So we go there with a special tool. We go to this device, the equalizing valve, so we can open it. So this will make a bypass, internal bypass. So pressure below will equalize with the pressure above. Now you can open your BOP with equal pressure. This is what we call the equalizing valve. This handle, which is, we call it manual lock. When you close any BOP, when you close it hydraulically, then you have to close it manually. Why we close it manually? To prevent the ram, the BOP ram, which is this one. This is the BOP ram, which is here. This is the BOP ram. To prevent the ram from going back. That's why when you open the BOP, you have to open it manually first, then hydraulically. This single actuator BOP is nice because this is the ram and this is the inner seal. This inner seal, which is this one. So we have two pieces, two sides. When you close, it will close, it will seal on itself, preventing the pressure escaping. So it acts as a blind. Even if there is a wire inside and you close, it will seal on the wire. You know why? Because the wire diameter is small and this is rubber. This part is rubber. So rubber will seal around small diameter. So this BOP is 2-in-1. But if we are using braided line or E-line, this system will not work. Even if we came to this blind, in the middle, we make a profile to seal around a certain size, a bigger diameter, like this one we have. We make this profile. Why? Because we need this to seal on a pipe 1.5 inch. So when you close on the pipe, and this is the other side, it will seal around the pipe. So now if you have a braided line, so we'll make a profile corresponding to the diameter of the wire. to seal around the wire, but rubber will not seal on braided line or E-line because we say pressure will escape from these braids. So we have to look for a different type of BOP. That's why we use what we call braided BOP, dual braided BOP. If you look at this BOP, which is dual braided BOP, it is two actuators. If you look at the ram, which is on top, this is normal ram, where we have an inner seal here and we have an outer seal outside. Look at the one below. We inverted upside down, where you will notice that the outer seal became down. Why we inverted? If it is a normal condition, it is designed to withstand pressure from below. If we invert it upside down, it is to withstand the pressure from above. That's why in braided line or E-line, when you close the two sets, as you see here, when you close the upper set, when you close it, this is the outer seal, this is the inner seal. And on the other side, this is the inner seal, this is the outer seal. When you close it, it takes U shape, preventing a well pressure escaping from this direction. But if we make it upside down, we invert it upside down, it is to withstand pressure from above. From where the pressure come from above? Because once you close both sets, by doing this, you didn't do anything yet, because rubber will not seal on braided line. That's why after you close two sets, you have to inject a grease here in between. This grease you injected, it goes up, the one on top, it will prevent in this direction. Then it goes down. So the lower one will prevent it. So the lower one is inverted, not to withstand the well pressure, but to withstand the grease pressure. And as long as your BOP is closed, you have to keep injecting grease because the grease is what makes the seal, not the ram itself. And this is the typical rig up of the braided line or E-line. Our primary barrier on top is not a stuffing box. It is grease injection head. Our secondary barrier is not two identical single actuator BOP, but it is two dual braided BOP. You see this dual braided BOP. So the first ram here is normal. The second one is inverted. We have an identical one where this third one is normal. The fourth one is inverted. And our tertiary barrier is not a Christmas tree because a Christmas tree cannot cut braided or E-line. So our tertiary barrier, it is a separate shear seal BOP. And this separate shear seal BOP, we said before, it has to be connected to a separate control panel. You can put it away from the location up to 200 feet. This is the shear seal BOP, which is the tertiary barrier. Because the tertiary barrier is always, which has the cutting capability, and sometimes we call it shearing barrier. Wireline parameters. 5 consideration require serious attention period wireline operation. Job planning, rig up and rig down, pressure testing, running hole consideration, and an emergency response. Let's talk about job planning. How to plan for the job. To plan for the job, you have to obtain well information. And I cry when I see people goes to the location, do a job without having the basic information about this well. Study well history. Guys, I'm not teaching you because I have a PhD in the States or a master's degree in England. I'm just a mechanical engineer, but start my life sweeping the yard and cleaning the tools for my operator up till being director for service company. So I believe in every single word I write in my presentation, where I said study real history. I face a problem one day in Iran, doing a job in Iran, because I start the job without having the will history. So having the will history will help you to design your job the way it should be and to do the job without mistakes. You have to have the whole history. And normally, when the client hand over the program to the service company, this book they give him, it should include the will history beside the will information, of course, and the job type that they are doing. Will history is a must. Tools and equipment inventory should have, we should know what do you have. Yani it is shame that I ask you for a pressure gauge 2.3 and you said, okay, boss, let me check my toolbox if I have it or not. This is not acceptable in all field. Pre-run checks on tools and equipment. I do believe in this statement to the end of the world. Yeah. Um, One day a crew uh, got instructions to move the wireline unit to do a certain job. So the crew prepared their toolbox, they lock it. The supervisor take the key, the lock key in his pocket, and they went home and the equipment left. The following morning, they went to the field. In the afternoon, the equipment arrived. He looked at it from a distance. Yes, that's unit number 3, so it belongs to him. The job was delayed for a couple of days. During these days, he was sleeping, eating, watching movies. And then on the third day, okay, let's go start the job. They wear the coveralls and helmets and they went to the location. He has the key of the toolbox. He tried to open the padlock. It doesn't. Tried once, twice, several times, adding WD-40. It doesn't work. So they break the padlock. They open the toolbox. But surprise everyone, half the tools are not there. How? How? This is another story. If we go back to the yard, they left before the equipment. So in the evening, another crew came. They need to work on their unit. They didn't have a toolbox. So they found that toolbox unit number 3, but he didn't have the key. So he broke the key, the padlock, used the tools. They didn't put it back, but the guy closed the toolbox and he was nice to have a new padlock. He padlocked it, he locked it, he put the key in his pocket. The unit left the location. The other guy doesn't know this story because he didn't double and triple check. So please double and triple check. Yes, I believe in that. The personal knowledge and the skills. I remember the words of my supervisor when we go for a job that was 25 years ago or more. Ahmed, grab 2 hands and go. Grab 2 hands and go means just take any 2 people. The crew is 3. Ahmed, you know the job, so grab any 2, maybe one office boy, one storekeeper, and go. Nowadays, no way. Each one we send to the location, he has to meet certain criteria, and he has to have a technical capabilities, and he has to prove that he has been through these training courses. I cannot send someone to do a job in H2S environment without having a valid certificate in H2S. I cannot send someone who can handle chemical without handling chemical certificate. I cannot send co-tubing supervisor or wireline operator without having well intervention course certificate that he passed this. So people have to know English because hate it or like it, this is the language that we deal with each other with. The crew might be an Egyptian guy, one from Kuala Lumpur, one from South Africa, one from Denmark, how to communicate with each other. We have to select one language so they can all understand it. Uh, Safety device and equipment. Okay. One day, yani, it was a stimulation job. It was in Abu Dhabi, and the company man went to check the equipment before they start rigging up. So the company man arrived at the location. He looked at the equipment, and then he looked for the supervisor, and he tells him, "Thank you very much. Please take your crew, your equipment, and leave." And the supervisor was totally shocked. What mistake he did? He didn't even start the job. But the answer came in the report that the company man made, that while investigating, while checking the equipment of the service company, he found, I don't remember how many fire extinguishers on location, but let's say eight, for example. Uh, he found eight fire extinguishers. All are certified. All they have this sticker that are certified, but none of them is in working condition. One certified but empty. One certified but has broken gauge. One certified but has no handle. One certified but has no hose. So they are all certified, yes, but none of them is working. So you have to check visually. Bring up and down, effective communication between the people, working location, the housekeeping, uh, the geometry of the job, the weather condition, and some days we have to stop the operation because of the weather condition, the wind speed, for example. Uh, the material selection we are using, rerun check on tools and equipment. I said double and triple check. You have to have enough backup and spares and locations. When we pressure test, our minimum pressure test is the maximum shot in pressure. We do recommend 1.2 and we do it in stages. You cannot pressure test from 0 to 5,000 one shot. You have to make it in steps. You go from 0 to 1,000, then from 1,000 to 20,000, 2,000, 2,000 to 3,000, but you cannot go one shot. In places where hydrates happen, do not test with water. Test with inhibited water, test with brine or seawater, but not with fresh water. Bleeding off is the same importance like pressure testing. You have to do it in stages, and you have to do it slowly, and you have to do it through venting system, not to the air. The drift run, regardless we are doing wireline or coil tubing, normally we do what we call drift run. The drift run is where we run with the tool, which has a minimum clearance between the OD of this tool and the ID of the production tubing or accessories we have in the hole, to be sure that we can run to the desired depths, no problem. And we also can pull out of the hole all the way to the surface without any problem. This is the meaning of the drift run in the wireline. Well, it's almost 1 hour. I will leave 10 minutes or so for your questions. I know that I was very quick, but this is how it is. It is just 1 hour. I need to do the wireline 1 hour while we do it normally in 5 days. Yeah. But let me go to your questions to see if you have any questions. Uh, could you please explain the pull heading from the last lecture, as the downloaded video in YouTube was not complete, although this is not part of the course, but sure. Yani, البول heading is one technique of killing the well, where you have to do what we call injectivity test. You have to be sure that البول heading is a squeeze. You squeeze the kill fluid into the formation. But to do that, you have to do injectivity test for the formation, because some formation are like check valve. You can produce from, but you cannot inject into. It's like the check valve, one way. So you have to check that the formation is permeable enough to accept this. That's why we do injectivity test. Once we did the injectivity test, we started bullheading. Bullheading is by squeezing the kill fluid or and whatever inside the tubing back to the formation. This is the killing. And normally we said normally the well will die between a tubing volume and double a tubing volume. Yes, we have some wells will die after pumping 10 times the tubing volume. But this is not the standard yet. Second question, Amy, how do we identify and differentiate stuffing box packing material for standard service and sour service by more visual inspection? Never depend on that by visual inspection. You have to have the certificate which tells you this specific packing is suitable for one, two, and three. This has to come from a third party inspection. Do not depend on visual inspection to decide is it for standard service or for sour service. Never do that, any please. It has to be done through certificates. What do you do visually is to check that it has no tears, it has no cuts. Yes, this is we do it visually, but do not rely. You know, Amy, if I'm doing a job on a dowel completion, it's a Christmas tree. We have a well which has short string and long string, and I need to do the job on the short string. This is the problem. So I went to the location. I'm in front of the Christmas tree now, and in my experience, I can tell you without any tags on the Christmas tree where is the short and where is the long. But if I didn't find tags on these valves telling me where is the long end, where is the short string, I will not do the job. I will postpone the job and ask them to put tags to clarify which is which. Although I can visually I can tell, but I will not depend on that. Third question from Enya as well. Is pressure testing still necessary for wells with artificial lift like ESP, where well head pressure is usually 0 psi or very low? Thank you very much. It's a very, very, very good questions. Uh, First of all, let us go to the API because this is our judge. When we go to the coil tubing API responsible for the pressure control equipment and operations, we use API RP 16ST. RP is always recommended practice. 16ST, where it tells you that when we come to the pressure categories, the first category we have it as category 0. What category 0 means is where your well head pressure is 0. So you have well head pressure 0. What is the minimum pressure control equipment pressure rating? 3000 psi. Although the well head pressure is 0, 3000 psi is a must. So please treat an artificial well as a live well. People will say, how? Yani, if we stop the pump, pressure will go to 0. I said, yes, but not immediately. It might take 15, 20 minutes. So you are dealing with a live well, but dealing with it as a dead well. No way. So yes, please deal with artificial lift like live wells regarding pressure rating, regarding pressure testing. Yes, it is a live wells. Regarding it's alive by itself or it's live because of someone else who is helping it, like artificial lift. Uh, Last question I have. Does low pressure system like cool bed methane production require the same BOB system setup as high pressure system? First, let us agree with each other. what do you mean by low pressure and what do you mean by high pressure? Uh, there is nothing called low pressure or high pressure. There is no line between the low and the high, but we have categories. The API puts it in category 0, category 1, category 2, category 3, and so on. Each category is from 2. Category 1, for example, is from 1 psi to 1500. Category 2 is from 1501 to 3500. These are the categories. And in each category, the API tells you what is the minimum pressure control equipment you have to have, how many barriers, what's the minimum pressure rating of this equipment, and even how to set up this barrier in your rig. So I do recommend you go and get a copy of this API, RP16ST. Remember that, RP16ST. Amy, again, during your previous lecture, you said riser is different from lubricator because of flange connection. Yes, I did. So is it right to use lubricator as a riser in a wireline, slick line, rig up? Up till today, we said a lubricator is thread connection. So in wireline, whatever the wireline is, a slick line, braided line, E-line, whatever it is, yes, lubricator we can use up till now. But when we come to the coil tubing, we cannot use any threads. So lubricator is forbidden. We have to use riser. All the connection I also mentioned that when we rig up coil tubing, all connection from the Christmas tree all the way up to the sky, it has to be flange to flange connection. Because I said flange will withstand the torque, while thread does not. So in wireline, we still use lubricator. In coil tubing, we cannot use lubricator. We have to use risers. Dr. Ahmed, I'm done with the questions. So it's the end of the session.
Engineer Ahmed, thank you very much. We will see you again Saturday, 6:30.
Inshallah.
Okay, sir. Thank you very much and enjoy your evening.
Thanks, everyone. See you Saturday, 6:30, inshallah, to talk about coil tubing.